functions, what they look like, all I'm going to do here is I'm going to pull up a search engine and I'm going to type in even functions. Okay, and let it do a search on even functions, then I'm going to select images. And if you take a look, that's an even function. Okay, well, that's not exactly even. You got to watch what you pull up online, even though it's titled even. Why isn't that even? It's not symmetric around the y-axis. To be symmetric around the y-axis, the y-axis would have to slice this puppy straight in half. So it'd have to be there at -1. So this isn't actually an even function. Whoa, we got to be careful what we look up online. Did you know that everything online is not necessarily accurate? How about that? Is that even or odd? That's even, isn't it? The y-axis slices it into two pieces. They're the exact same. They're mirror images of each other. Okay, so that would work. How about this one? Is that one an even function? Yeah, because once again, the y-axis slices it right in half. You have two mirror images. Let's see here. Let's see what else we can find. Well, let's take a look at this one. On the right, is this an even function? Yeah, once again, and I think you're probably starting to get bored and thinking, gosh, how long is he going to go on with this? Cuts it into two slices. Let's take a look at some odd functions. Let's look at this one. On odd functions, you want to look at where, oh, this is interesting, it's moving around on us. Okay, we'll go to another one that we can actually, okay, maybe I can stop it there. See if it'll, nope. Okay, so much for that idea. We'll go back up and we'll do a quick search for some odd functions. Thought that one was going to cooperate. Ah, here we go. Here's one that will cooperate, I think, I hope. For an odd function, you look at the origin right there. And imagine driving a nail in there and spinning it, just like a spinner for a game, one of the board games or something like that. And if you spin it 180 degrees and you get the exact same graph back, it's an odd function. So for example, if we spin this 180 degrees, that point up there is going to rotate and be down here. This point down here is going to rotate and be up there. This point right here is going to rotate and come down. And you get the idea. Okay, so there's an example of an odd function. Let's do a quick scan. See if we can spot, hey, is this an odd function? Is that one odd? Well, the first thing to look for is, can I drive the nail through the origin? Well, I can, but if I drive a nail through the origin, is it even going to hit the graph? No, so you can't spin it, can you? Oh, rats. So we can't put that one on a nail. It's not even, it's not odd, it's neither. It has some of the looks of an odd function, but it is not in the location that it would need to be. Hey, what's this? Even or odd? That's an even function. Okay. Even and odd functions. Let's see what happens when we look this up. Here we go. Let's take a look at these. First one, upper left. Even or odd? Well, you got to kind of pretend that they hit the origin, right? Because that's a hand-drawn picture, so it's not quite perfect. So if you pretend that it hit the origin, you could drive a nail through there and spin it, and it would wind up looking the same, either up, right side up or upside down. This one's a little bit better. Even or odd? It's odd, isn't it? Because you can drive the nail through. How about this one in lower? You can slice it in half, even. Same thing with the one over to the right. Slice it in half, it's even. Oh, what else do we about this one? Even or odd? So what's the verdict on this one? That's right. Way to go. It's neither. Oh man, you got to be kidding. Well, think about it. If we drive a nail through the center at the origin and we rotate it 180 degrees, is it going to look like the same thing, or is it now going to look like a mountain? Okay, so it's not an odd function. Second, to be even, we could take and slice right along the y-axis. And if you slice right along the y-axis, do you get two of the same thing? Nope, so it's not even, it's not odd, and if it's not even or odd, it must be neither. Are you good with these? Just making some sense? Wanted to make sure that you had a little bit of practice that this stuff works. I didn't want to just go running off and leave a mess before we move on. All right, there are a considerable number of functions that are what are called piecewise functions. Piecewise means that within different values of x, you use a different function. Taxes are an example of this. You may or you may not know how taxes actually work. What happens is, with taxes, everybody's treated the same. Gosh, Chuck, that's not what I've heard. Well, everybody's treated the same in that I'm not sure exactly where the breaks are. I'm making these breaks up. So let's say for the first $20,000 that anybody makes, they owe nothing. I'm not sure where the breaks are, but it works kind of like this. If you make a total of $30,000, the next $10,000 is taxed at, I don't know, 4%. So you'd pay $4,000 on the next $10,000. Well, wait a minute. Do you get taxed on the first 20? Nope. Okay. Then up to $50,000. Well, wait a minute. From here to here is a jump of $10,000. And then from here to here is a jump of another $20,000. On this next $20,000, maybe you get taxed at 6%. And what winds up happening is everybody winds up being treated the same. As you go up, well, let's make this 100,000. This next 50,000 might be taxed at 12%. And it keeps going like that. So whether you make 20,000 or 100,000, the first 20,000 is taxed at the same rate. And then the next 10,000 and the next 10,000, each 10,000 is taxed differently. And they just keep adding it on and adding it on until they run out of your income. This is an example of a piecewise type of function. For each section, there's a different rule, maybe 4%. For this section, 6%. For this section, 12%. So piecewise functions have, within different values of whatever the domain is you're working with, they have different rules that apply to them. We've talked about it before with mailing stuff. There are different rates at which you are charged based on the weight of the thing. Anything between 1 pound but less than 2 pounds is charged, whatever it is, this rate. Everything from 2 pounds up to just less than 3 pounds is charged at the next rate. Okay. One example of a piecewise function that the book provides, okay, is this one. Okay, so suppose you're asked to evaluate f at -3. Well, that says we're going to take -3, we're going to plug it into the function. But to plug it into the function, we have to decide which rule do we use for the function. Well, since it's -3, that means it lands in this first grouping, doesn't it? Which would mean that we're going to get something or other squared minus something or other. The x is just holding a space, and in each of those spaces we put a -3. So this would give us 9 minus a -3 the value would be 12. If you have an x value, where am I? There it is. If you have an x value in this range, what rule are you going to use for that? No, zero's in the first, second, or third range. It's in the second, isn't it? Because 0 is between -2 and +2. So this is going to give us negative whatever the number is cubed. Plug in 0, and we get -0. So did you put down -0? Or is -0 the same as +0? They're both the same, right? Which just gives you 0. And if we have something like f at 4, that's going to put you into the third range, which is going to be 4 minus 4 times something or other, and the number that goes in, this is all 4s, is going to be that. 4 minus 16 is a -12. Now, here's one for you. Suppose you're asked to evaluate something like f of 7. What are you going to do with that? Well, does the first rule apply to it? No. Because the first rule only talks about numbers between -5 and -2. Well, this isn't in that range of values. How about the second rule? That doesn't apply either. How about the third rule? Nope, we're not in the third rule either. This value here is not in the domain of the function. Our domain runs from -5 to +5. Anything outside of that is undefined. We don't know what it is. And whatever you put down in the way of a number, you're just making it up. Okay? So this winds up being a scenario where, gosh, this is outside of the weight range. So for example, if you walked into the post office and said, I need to mail something, and they said, okay, well, where is it? And you say, I'll be right back with it. And you lead in a full-grown elephant. What are they going to say? That's not us, dude. We do not ship elephants. It's outside of our capabilities, isn't it? Okay. So what happens is if you get something that's outside of what that function is designed to work with, it's possible. It doesn't mean you're bad and you're awful and you've made some mistake. But what it means is that whatever has been brought in isn't going to work for this set of rules. And it's put down that it's undefined. And that's a perfectly fine answer. It's okay. It's okay if it's undefined. Everybody good with evaluating these things? Pretty straightforward stuff. Easy going. Okay. Sketch a graph of this function. Now this one's different than the other one. How do you know? Well, I looked at the domain. This one starts at -4 and runs up to +4. That's a little different than the last one. Okay. Sketch a graph, determine if it's continuous, and solve the equation where it equals 1. F of x equals 1. Well, we'll have to doodle with that a little bit. First thing let's do is let's get a graph of it. To graph this, you've got to be careful. You're going to have to graph it in pieces. When you have a piecewise function, you do each section individually. So for example, for this, this graph is what shape? One in the red. What shape is that? Parabola. Opening up or down? Up. Is it skinny or flattened out? Flattened out because it's a half. And what does the -2 on the end do to it? Shifts it down, doesn't it? So we would shift down 2, kind of flatten it out, and go like that. how far can we go with that particular parabola? Where do we stop? Or do we just keep going? Do we just draw it like that? Well, if you take a look here, we start at -4, and where do we stop? At 0. So that means that we need to take this and draw it starting like this, coming over to 0, pretend that that'll hit 0. Maybe I can actually draw it this time and get it to hit 0. There's that part done. Does that make sense? Then what you do is from 0 to 2, 1, 2, we graph this line. If x is 0, if x has a value of 0, it goes into the first slot. You get -2. If we were to start this second portion at 0, where would it start? Do you see it would start at -2 as well? It's going to be a line. It's going to have a slope of 2, so it's going to go up pretty fast. Okay? And it's only going to extend over to the value 2. Now what I did was I plugged in 2, so I get 2 times 2 minus 2. I'm going to draw a line that ends there. There. The next thing then says, okay, start at 2 and go over how far? To 4. And this time, instead of being line, or instead of it being a parabola, what's the shape of the function now? Well, it's 2. How does 2 graph? It's a horizontal line that just goes straight over, and it says less than or equal, so we can equal 4, so you get something like that. Piecewise functions are not horrible to graph. You just have to be content to take it one little piece at a time and deal with where does each little piece start. It asked if it's continuous. Is this continuous? Yeah, there aren't any breaks in it. So the answer to that is, yep, it's continuous. Now, here comes a tricky one. Solve the equation where, bless you, where the function equals 1. Now remember, f of x is the same thing as saying y equals 1. Well, a way to solve that is to draw a line through at y equals 1 and take a look at, well, gosh, where are the answers to that? They're at those two locations there, aren't they? Y will equal 1 on this first line. Well, this says we have a 1/2 x squared minus 2 equals 1. Equals a blob. Can you solve that? Yeah, that's just routine algebra, isn't it? So it's going to be a -1/2 x squared equals 3. Now what? Multiply by a -2? Ooh, are you seeing a problem here? So we're going to get a -2 times the right side is going to give us x squared equals -6. Bless you. Is that possible? Can x squared equal -6? No. So what that tells us is that answer, whatever it is not in the range of values that we have going. Does that make sense to everybody? How about, let's see if it's, yeah, okay, so there's B, the coordinates can be found, da da da. Okay, so if we take a look here, we can see, well, we've got a solution over here. Here's our y equals 1. Okay. Now, let's see here. I may have messed something up here because they've got a positive 1/2. Oh, do you see what I did? See where it's a negative 1/2 x squared? Is it supposed to be a negative 1/2 x squared? No, it's supposed to just be positive 1/2 x squared, so we'll get rid of that, which will get rid of that, which means x is going to be equal to the square root of 6. Now remember, when you do square roots, you can do plus or minus. Which of those x values is going to work in this case? Does x equals a positive 6 work on this domain? It doesn't, does it? Because it says we have to be between -4 and 0. Is the square root of 6 smaller than 4? It is. So what winds up happening is this point right here is going to be the square root of 6, but it's going to be the negative square root of 6, and the y value is going to be 1. The other location where we can find it equal to 1 is on this line. Well, that says that there we need 2x minus 2 equals 1, or 2x equals 3, which gives us x equals 3/2. So the other point would be 3/2 for the x value, and then 1 for the y value. So you've got two different places there we can find an answer. Does that make sense? The thing to be mindful of is you first need to get a graph, draw a line through representing whatever the value is you're trying to find it equal to, and then determine which sections of the graph might even be involved. Everybody good with that? Okay. Let's take a look at some data here. We have the unemployment rates down in Brazil from 2010 to 2020. Hey, what's the deal with this 2020 business? How'd they get the unemployment rates for next year? Has the government decided how many people are going to get hired and fired and that's it? Or is that a guess? It's a guess, isn't it? Okay. When you are looking at data, you need to decide what type of a model will fit it best. And in deciding what model will fit best, you first need to plot the data. Now, when you plot the data, we're going from 2010 to 2020. So I could put the 2010 here, 12, 14, 16, there's 18, and 20. Does that make sense how I'm doing that? The percent is going to go up to 10, so this might be 2, 4, here's 6, 8, 10. And now we can just go ahead and plot our points. At 2010, it's a little bit over 6%. So it's about there. 2012 is going to be 5.48. 2014 was a little bit lower yet. Like that. 2016 went crazy, didn't it? Went up to 19%. Then 2018 went up a little bit higher, a little over 10%. And then 2020 is forecast to be there. Something happened there between 2014 and 2016, didn't it? Things went not so great. And if you play connect the dots here, You get a model kind of like that. Now, one of the important things with understanding the various polynomials is looking at that and saying, whoa, that's a cubic. One way to tell it's a cubic is by the number of high and low points. The high and low points total adds up to 2 of them, which means it's a cubic. Okay? If we had 3 high and low points, then it would be a quartic, a 4th degree. If we had 8 high-low points, it would be a mess, Chuck. What degree polynomial would it be? 9. Okay. So you can work things through like that. And on the graphing calculators, it's kind of neat because you can put the numbers in, go check and say run a cubic regression on it, and boom, it'll come back with the equation for you. Okay. Now, it says find a polynomial of degree 3 that models, graph it and the data together, estimate the unemployment in 2024. Hey, based on what's going on here, where do you think the unemployment rate's going to be in 2024? Will it be above or below 8%? In 2024. Let's see, here's 22. And there's 24. If things continue the way they are now, where's the unemployment rate going to be by 2024? Well, it's going to be coming down a little bit, isn't it? It's going to continue down like that, maybe down around 6%. But that's assuming things continue the way they are now. Could things change in 2022? Yeah, and it could shoot back up. You know, you're just hoping that it's going to continue along that trend and folks are going to get jobs. Okay. All right. Real important. In part C, it said, did you interpolate or extrapolate? Interpolate means it's inside of the range of values that you have. So for example, here, up through 2020, suppose we were to try and figure out what the unemployment rate was in 2017. Could you read that off of this graph? Yeah, it'd be around 10%. That's interpolating. When you go outside of the graph, outside of the data, extra means outside of, like extraterrestrial life, right? It's life from out beyond. Okay. So what's going to happen here is the extraterrestrial, the extrapolation means do something from outside. That would be something like 2024 where we're guessing where things are going to go. All right. Here's what you get when you wind up graphing it on the calculator. Okay. It is a cubic. You can see your data points along through here. You can see things fitting pretty nicely. Does it fit perfectly though? No. When you do a regression, regression's a fancy word for finding an equation that goes through the points. Will the regression hit the points exactly? No. It's hopefully just going to come close. Now, one of the things to be careful of is if you're doing a regression, you know you could tell a calculator to do this linear and it would do it. It would go like this and say, okay, there it is. Something like that's about it. There's the linear and it's happy. Is that a good way to handle that data? Probably not. You could probably even fit this with a parabola. Like that. Is that a good way to handle the data? Yeah, probably not. So you need to be aware that when you're using a calculator to do this regression on these things, it may or it may not be an appropriate model for that particular set of data. How many of you have like an 83 or an 84 with you? I'm looking around, I'm seeing a fair number. How many of you have one? Okay. If you have one, would you be willing to share or let somebody around you who doesn't have one see what's going on? and I'll show you how to do this regression on the calculator. Okay. And I'll leave this running so you can at least hear the audio portion of how to work this. Okay, so I'm going to go to the document camera, and there we go. I'm going to use the data from that table. Now, there are a couple ways to do this with regression. Okay, there we go. Turn your calculator on. Go zoom in a little bit. That'll be about enough. Okay. First thing you want to do on your calculator is clean things up. So I'm going to press y equals, and I want to make sure that there are no equations in y equals. When you press y equals, if there are any equations, press clear to get rid of that equation. Move down to y2, press clear, move down to y3 until you're out of equation. The other thing that you want to do while you are here on this particular window is, see in the upper left where it says plot 1? I'm going to kind of take a risk here. With your cursor, move up to plot 1, press enter so it's highlighted. Now notice if I press enter again, it's not highlighted. See it? It's not shaded. So I'm going to go up, press enter, and we'll see what happens. Some of your calculators may do some strange things. Hopefully it'll work for everybody. Okay, so the first thing you do is you get rid of any old equations. The next thing we need to do is we need to put the numbers into the calculator that we have, our data. So I'm going to press Stat. Stat's in the second row. It's the third button. And I want to edit right there. So I'm just going to press 1 or press Enter. And whoa, look at there. In list 1, I've got a bunch of numbers. And in list 2, I have a bunch of numbers. Does that make sense to everybody? To get rid of these numbers, I'm going to move up so that L2 is highlighted. Do not press delete. Don't press delete. Instead of delete, press clear, which will clear the column. Delete would delete the column. Press clear, then press enter. Move over to list 1. Move up, highlight L1, and once again you want to clear the column, so I'm going to press clear and enter. There. When it comes time to plug the numbers in, you have to figure out which are the X values and which are the Y values. Let's see, we have years and unemployment rate. Which one controls the other one? Does the year have an influence on the unemployment rate, or does the unemployment rate decide what year it's going to be? No, it's the other way around. The thing that's in control is going to be your X. So our times, our years, are going to be our X values. Okay. Should I put in 2010? You can. Or if you want, you can drop off the 2000s and just put in 10, 12, 14. It'll give you different equations. But they'll all work. Then, for your Y value, which is your list 2, going to put in the interest rates. 6.75. The next interest rate. The next employment rate is 5.48. The next unemployment rate is 4.84. The next unemployment rate is 9.19. And let's see here. Well, what's the deal? Why? I've run out of space, haven't I? I've got my 2018 data of 10.4, but if I put 10.4 in there, that's 2018, and look, there's nothing there. What's the deal? Well, if you take a look over in the list 1, I'm missing 10, aren't I? If you do this, the easy way to fix it, instead of clearing out all your lists and starting all over, is to press Insert. Insert is up above Delete. See the Delete key? Above it is INS, so you want to press second Insert. Now, look what it did. It put an extra space in there, didn't it? Right now it says 0, but what I really want in there is 10. Boom. And then all you have to do is check and make sure things are lining up, numbers-wise, and we didn't have to erase anything at all, did we? And now for 2020, we can go ahead and put in what the unemployment rate is for 2020, which you're anticipating it to be 10% even. Does that make sense? Okay, so let's take a look at what's going on here. Our X values go between 10 and 20. Our Y values go between about 6 and 10. What we need to do is to create a window to see what we're looking at. We have in this room 3 windows. They're aimed in specific directions, aren't they? If you look out that window, can you see your car in the parking lot? Why not? Yeah, the window's not faced in the right direction, is it? If I was to take a drill and drill through this front wall, a little bitty hole, would you maybe have a chance of seeing your car? Unless you're parked in the back. Okay? But if I made a bigger hole, would you have a better chance of maybe seeing your car? Yeah. Now, if you're parked in the back, we got to cut several holes to get through the walls on the other side of us, don't we? But the whole point here is, depending on where you point the window, you're going to see different stuff. Depending on how big or how small you make the window, you can control how much you see as well. What we need to do is we need to adjust the window so that we can actually see the data. Top line, second button says window. Whoa, Chuck, you got a mess on there. Starts at negative 25 and goes to 150. Do we need to start at negative 25 with this information? Well, it starts at 10. I'm going to start mine at 5. Well, why is that? So I've got a little bit of space to the left. And it goes up to 20, doesn't it? Well, I'm going to leave a little space on the right as well. I'll go up to maybe 25. And the third line says X scale. What do you want to go by? 1s, 2s, 5s? I think we'll probably, I'm just going to go by 5s. Then for the Y minimum. Well, the minimum on our data was 6.75. I'm going to go down a little bit lower than that. I'm going to do something like maybe 2. The highest was up to 10, so maybe I'll go up to 12%. From 2 to 12, I guess we could go by 2s and that would work. The very bottom line where it says XRES, leave that alone. Okay, so what we've done is we've put in the data, we've deleted any old equations, we've set the window. Let's go ahead and try graphing it. Let's press the graph key, okay, and see what happens. Did you get anything on your calculator? Okay, some people are saying yes, some are saying no. If your calculator did not graph, remember earlier I said let's try skipping a step and see if we get lucky? Okay, here's the step that we skipped. On your calculator, upper left, it says stat plot. To get to that, you press the blue key, then stat plot. On the window, it gives you plot 1, plot 2, plot 3, plot 4. We want to go to plot 1, and we're going to press enter. Everybody okay so far? When you get there, first make sure that on is highlighted. Okay, yeah, that'll cause a problem. If it's not highlighted, use the left arrow to move the cursor over to the word on and press enter. That'll turn it on. That may fix some of them, may not fix all of them. Next line says type, as in type of graph. we want to choose the first, which is a scatter plot. It's just going to do the points. So if you do not have the first type of graph highlighted, move the cursor to that and press enter. Then you move down to XList. Your XList, where did we put our X values? Put it in list 1, didn't we? So that XList should say L1. If it doesn't, then what do? Well, it's easy to fix. Down at the bottom of your calculator, see where the number 1 key is? Above it, it says L1, doesn't it? So what you do is you move the cursor to where it says XList, then you press the blue key and the number 1, and that'll put L1 into your XList, which means look in list 1 for your X values. Hey, guess what the Y list needs to read? L2. So you can move down to L2 if you need to. L2 is located on the number 2, so you press the second, which is the blue key in the upper left. Then you press L2, and that'll put in a list 2. Then the next thing you do is you pick out how do I want it to plot them. There are different ways it'll plot. It'll plot using little boxes. It'll plot using little crosses or just using dots. I was kind of like the crosses, but does that mean that you're wrong if you pick something else? Nah, just pick whatever. Okay, now that you've got all that done, now try pressing graph and see if it works for you. God willing, it'll work for everyone. Please? It worked. Yahoo! Okay, did anybody not get a graph, or is everybody okay? Is everybody good?
Mine is like a box at first.
Okay, so go back.
It's fine now, but
Oh, before it was?
yeah, with the box. I thought it was great.
Yeah. So you may have had the wrong type of plot
Yeah, it
on.
was just the wrong.
Okay, well, good. Now, are you going to have to change that very much in this class? No, you'll never have to change that again. The next step is getting the equation that fits through there. Okay? To get the equation, everything we've done so far is to plot points and look at that and say, well, I guess that's a cubic. Looks kind of like a duck's back and the head of a duck there. Okay? So we could say, we could try fitting this with a cubic and see what happens. Okay, to do that, you press Stat. Up at the top on the ribbon or the toolbar or whatever you want to call that, move over to Calculate. Then, down the list, do you see option number 6 where it says cubic reg? REG is short for regression. They just ran out of space. So what you want to do there is press 6 and enter. So you just have to press 6. Is there anybody who has a display different from this one? You just press the number 6. Okay, so we got one person. Does yours have down at the bottom calculate and up at the top some other stuff?
I think all three of us would have the same issue. As long as looking at your Y list, it says calculate at the bottom.
I think I'm going to go to the math level.
This is a kind of a lengthy procedure, isn't it? Yeah, okay.
You said 6, right?
Right, you're fine. Up at the top here it says cubic progression. Okay. Are you getting cubic progression?
yeah,
You're okay. Okay, great. Now, what's going to wind up happening, for the three of you, your display's a little bit different.
Will this make it more complicated for us?
No. Yahoo! It isn't more complicated, just different. All right, so what's going to wind up happening here, if you have a display like this, here's how you work it. If you don't have a display like this, I'll deal with it in a minute, okay? So your brain can take a rest for a minute. Okay, what you want to do is to avoid having to type a bunch of stuff, correct? There are two ways to do this. One is to just press enter and say, whoa, Dogers, whoa, look at that. Now I've got to copy that all down on the paper, and then I've got to enter it all into the calculator. How many people are really looking forward to that? You aren't? Oh, well, there's another way to do it if you don't want to do it that way. The other way to do it is to press Stat, come over to Calculate, option number 6. Now, don't press Enter. What you want to do next, if you don't want to do all that typing, is come down to Variables. Variables is right next to the clear key. You want to move in the ribbon or the toolbar over to Y variables. We are not using parametric or polar coordinates. It's not winter yet. Nah, that isn't what polar coordinates are about. You want a function. Say just press 1. Now, you've got a choice. Which slot do you want to save your equation in Y1, Y2, Y3? Well, probably Y1, so I'll just press a 1. And look how your display has changed. You see it now says cubic reg in Y1. Watch what's going to happen. Press Enter. Well, gosh, Chuck, it didn't do anything different. Actually, it did. Press Y equals. Whoa, what did it just stick into Y equals for you? The whole equation. You don't have to copy or type any of that. Then you can graph it to see how close does this fit. Does that fit the data pretty well? So there's an equation. Now, if you have the other type of display, you've got your X list. Make sure it says L1. Okay? So for the folks back in the corner, you've got your X list, you have your Y list. Your Y list is going to say what? L2. The next, does it say store reg? Oh, frequency? Move down 1. Just take the arrow and move down to the next line. Yeah. On this frequency, just skip it. Then it says store reg. And there's nothing there, is there? Move the cursor over to here, beside the store reg. Now, remember how we just went through the variables and all that stuff? No, I didn't really remember it, Chuck. I wasn't paying attention. You said don't pay attention. That's fine. We're going to do the exact same thing here.
So in the frequency, it says, in my understanding, it says L2. Should there just be nothing there?
Yeah, I'd clear that. Okay, so you get down here to store reg. What you do first is you press variables.
Is that vars?
Vars, yes. You press vars. They're right next to the clear. Then, up in the top, you move over to Y variables, Y vars. You see that? Then it gives you function, parametric, polar. Then you choose option 1, function. Then you will have a bunch of Y values, Y1, Y2, Y3, Y4. Pick wherever you want to put it. You may want to choose Y1, which would just be the number 1. And when you press 1, it'll bring you back to the screen where it shows the store reg, and beside it, it'll now say Y1, which means store the regression in Y1. Then what you do is you press down arrow to calculate, and guess what you do now? Press enter. Woohoo, it's there. Then you can check it to see if it really worked by pressing graph. And it should give you the data, and then it should give you the equation.
It worked.
It works. How about that? Okay? They've got lots and lots and lots of different versions of this on YouTube. Okay? Now, if you're thinking, whoa, I want to do this again, you can clearly go to the math lab. You can come to office hours. I'll gladly work with you. Over the weekend, if you want, you can hit YouTube and just look up regression on, and then whatever you have, CI83, CI84, whatever it is. And there'll be more movies there than you'll care to watch. And they'll step you through various steps on how to do this. Are you okay? It's not that painful, is it? It's painful if you don't have the calculator. Okay? Is everybody good? Are you all okay? I was talking to some folks in an earlier class, and they said the library is all checked out on calculators. Apparently they're getting a big run on them. Okay, so what's going to happen? Well, gosh, it's 2 minutes, 2 seconds after class is over. Uh-oh. Quiz will obviously be take home. Take it just like what you would here. Okay? Would you open your notes in your book here? No. Would you run over to the math lab to get help with it? No. Would you go online to get help with it? No. Don't do any of that with it, because the purpose of quizzes is to give you a checkup on how is it going. Okay? That's right. In the long run, you're hurting yourself. That's exactly it. Obviously, I can't follow you all weekend. It's on your own honor. It's on your word. Okay? So, here are copies of the quiz. When are these due? Monday, the beginning of class. Okay? Go get them. Make sure you show your work, and I hope you have a great weekend.